All right, let's jump right into this explainer. Today, we're tackling something that seems so incredibly basic on the surface, but is actually ruled by some strictly intense scientific protocols. We're talking about dirt. More specifically, how field techs and scientists navigate the highly specific rules of agricultural fieldwork to grab that absolute perfect soil sample.
It's honestly a fascinating question, right? How in the world you capture the entire story of a massive farm in just a single bucket of dirt? Well, before you even think about touching a shovel or an auger, you've got to realize the massive stakes here. Bad sampling totally distorts your data. It's really that simple. If you mess up the collection process, you completely ruin the test results, which basically renders all that expensive lab analysis totally useless. You're essentially building the entire foundation of your agricultural planning on a completely flawed baseline.
To make sure that never happens to us, we're going to walk through the exact step-by-step life cycle of a field sampling assignment. Consider this your ultimate cheat sheet: dividing the field, taking soil core samples, calculating sample quantities, timing and frequency, and finally handling your soil samples.
Starting things off with Section 1, dividing the field. We need to look at the macro level first, figure out exactly where we should, and just as importantly, shouldn't be digging.
When you're out there sizing up your land, you absolutely must avoid what we call odd areas. We're talking eroded spots, turn rows, abandoned farmsteads, and feedlots. You either dodge these spots completely or you sample them totally separately. Why? Because they've got highly unusual soil properties that will completely skew your entire baseline. Now, when you do finally find those nice, uniform areas to sample, here's a golden number you need to burn into your brain: 20. Specifically 0 to 20 centimeters. That is your standard tillage layer depth. The absolute golden rule here is that you have to keep this exact depth consistent every single year. Maintaining that identical depth is literally what guarantees an accurate, reliable comparison of your soil tests over the long haul.
All right, moving right along to Section 2, taking soil core samples. Let's zoom in on the actual physical extraction. Now pay attention to the word undisturbed here. A soil core is an individual sample taken from one single spot, and it has to remain completely intact. You need that original structure so you can accurately analyze physical properties like bulk density and porosity. Typically, you're collecting these in 100 or 400 cubic centimeter volumes, and you're pulling from at least 2 spots per location. Once you're actually out there pulling those cores, you've got a choice to make about your sampling pattern, and you'll see this comparison pop up all the time. Random sampling? Yeah, it's way faster and saves a ton of time, but you definitely run the risk of missing areas, making your data way less representative. Grid sampling, on the flip side, is the absolute gold standard for long-term soil assessment. Sure, it takes a lot more time to set up, but it guarantees the whole area is represented. Because you're hitting the exact same locations, you get significantly less year-to-year variation. Now, if you aren't doing those undisturbed cores and you're using an augering technique for composite mixing instead, you're going to follow this exact flow. Collect the dirt with the auger, toss it into a plastic pail or bag, and mix it up. But here is the critical part. You absolutely have to use separate bags for your surface soil samples versus each subsurface depth you sample. Mixing your depths is a massive rookie mistake because you have to avoid cross-contamination between those different earth layers at all costs. Okay, bringing us to Section 3, calculating sample quantities. Now that we know how to dig, let's figure out exactly how much dirt we need to haul out of there. Here's another essential metric for you, and honestly, just a great rule of thumb to keep in your back pocket. A standard sampling plot area covers roughly 8 to 10 hectares, and for those of us using the imperial system, that converts beautifully to exactly 20 acres. To properly cover that 20-acre plot, you need to hit a very specific ratio: 15 to 20 sampling points for the surface and 6 to 8 points for the subsurface. Hitting these exact numbers is what gives you a truly reliable estimate of the field's average nutrient status. Basically, more representative sampling simply equals much more reliable mean values. Moving into Section 4, timing and frequency. Because let's be real, the best physical sample in the world is completely useless if you pull it at the wrong time of year. The big thing with timing is keeping your conditions consistent. You really need consistent weather when you're pulling these samples. But the overarching absolute rule here, you must always sample before any major physical agricultural activities or land use changes go down. That means grabbing your samples before tillage, before fertilization, and definitely before harvesting. And hey, if you're working in forestry, you collect before any land disturbance happens whatsoever. So you actually have a true reference point. All right, stamp this number into your memory right next to the number 24. In agriculture, you need to be out in that field pulling your soil samples exactly 2 to 4 weeks before planting and 2 to 4 weeks before applying any fertilizer. Which brings us to our final stretch, Section 5, handling your soil samples. You've done all the heavy lifting out in the field. Now we just need to make sure the lab gets exactly what they need. For your standard composite samples, the name of the game is keeping them dry. You've got to avoid sampling in moist areas altogether. And more specifically, ensure you air dry your samples to protect them before they even get to the analysis stage. But notice the massive difference here when we pivot to specialized samples. While those undisturbed samples just need to be kept safe in their steel cores or thick plastic bags to maintain their structure, biological test samples are a completely different animal. For biological tests, you must use fresh soil, you've got to store it at cold temperatures, and you have to prep it incredibly quickly for laboratory incubation. Why? Because you have to stop microbial activity from mineralizing the soil organic matter. Freezing that biological clock is literally the only way you're going to get accurate nitrogen measurements. Taking a step back and looking at this ultimate summary cheat sheet, which pulls together everything we just explored, from dodging those odd areas and hitting that 15 to 20 surface point metric, all the way down to handling biological samples in the cold, it really highlights just how incredibly meticulous this scientific process is. So I'll leave you with this final thought. If soil truly is the foundation of all agriculture, the literal lifeblood of a farm's entire yield, how confident are you that your next sample is going to tell the true story of your land?